Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the fat characteristic. Fat characteristics. And in this, first of all, we are going to discuss the first characteristic of the fat is saponification value. So first of all, I'm going to define you this what is saponification value. Saponification value is simply it is defined as is a measurement of of the average molecular weight of fatty acid, molecular weight of the fatty acid in a sample expressed as number of milligram of potassium hydroxide, that is your KOH, required to saponify 1 gram of fat. KOH required to saponify 1 gram of fat. 1 gram of fat. That means that how milligram of this potassium hydroxide are required so that we can saponify 1 gram of fat. This is called what? This is called a saponification value. And this saponification value is used to measure the average molecular weight of the fatty acid present into a sample. And this saponification value are also used to determine the oil quality, and it is used to it is also used to determine how suitable the oil for making the fat oil for making the soap. Okay, now if the saponification value is high, then it will be better for this purpose, for the making of this soap. If the saponification value is high, then it is better for the soap making, soap soap making. So this is about the saponification value. Now come to the next slide, that is your introduction slide. We all know that this lipid present into a food are what they are subjected to many type of chemical reaction when it is stored or processing. Okay, when we process the lipid or when we process the food product or store that food product, then the lipid present into a food, they give different chemical reaction. Okay, now some reaction are what they are desirable and some reaction are what they are undesirable. So we have a effort to make that the effect of this reaction should be minimized, and there is different laboratory technique which is used to characterize the which is used to characterization of the fat and oil. And characterization of the fat or oil are totally based on the composition of the fat and oil, or structure and reactivity of this fat or oil. So that's why we have to characterize this, we have to determine the characterize of this fat, that is your saponification value. Now see what is written in the slide. Saponification in a food are subjected to many chemical reaction, okay, during a processing and storage. While some of these reaction are desirable, that means that we require, and others are undesirable, that means that this is not required. So efforts are made to minimize the reaction and their effect. Okay, so what should we do? We have a effort that reaction or that reaction should be minimized, and their effect should also be minimized. And the laboratory deal with the characterization of fat and oil with respect to composition, structure and reactivity. Okay, now the next one is the objective of this experiment. The objective is that we have to determine the saponification number or saponification value of what? of fat and oil. Here the food sample are what? Here the food sample are the fat or oil. Food sample. Okay, now the next one is your principle of this experiment. Okay, we all know that saponification is the process of treating a neutral fat with the alkali. Okay, the saponification is what? Saponification is the process in which we treat the neutral fat with the alkali and breaking it down to a glycerol and a fatty acid. Suppose that this is your neutral fat when they react with any alkali. Okay, when they react with the alkali, then what happened? This fat are dissociate or break down into a glycerol and fatty acids. Okay, and the saponification value or a number is defined as the amount of alkali needed to saponify a given quantity of fat or oil. Okay, how much amount of alkali we require so that we saponify the given quantity of oil or a fat, and it is expressed as milligram of potassium hydroxide is required to saponify the 1 gram of sample. That I already told you in the first slide that this saponification value is defined as how much milligram of potassium is required. Sorry, potassium hydroxide is required to saponify the 1 gram of sample. Okay. Now, excess alcoholic potassium hydroxide is added to the sample. Which type of potassium hydroxide is added into a sample? Excess alcoholic potassium hydroxide. The solution, then after that we heat the solution to saponify the fat. Suppose that this is our sample in which we added the alcoholic potassium hydroxide solution. Okay, hydroxide solution. Then what should we do? We heat it. We heat it, and when heated, then why we heat it? So that the fat will be saponified and the remaining unreacted potassium hydroxide is back titrated with the sterilized hydrochloric acid. Here we titrate with the HCl, and the indicator that we use during this process is what? Is a phenolphthalein indicator, and we calculate the amount of reacted potassium hydroxide which is used to determine the saponification value. So this is the principle of the determination of the saponification value in a food sample, that is your fat or oil. What should we do? We treat this neutral fat to a alkali, and it is divided into glycerol and fatty acid, and saponification value is defined as amount of alkali is needed to saponify the given amount of fat or oil, and it is expressed as potassium hydroxide. Here alkali is what? Here alkali is a potassium hydroxide which is required, milligram of potassium hydroxide which is required to saponify the 1 gram of sample. And the potassium hydroxide that we use is alcoholic potassium hydroxide. We added it into a fat and then we heat it so that the fat will be saponified, and the unreacted potassium hydroxide is titrated with the sterilized hydrochloric acid. Okay, so now the next one is your chemical used in this experiment. We use first chemical, that is your ethanol, and case number 64-17-5, and the hazard related to this experiment is, sorry, this chemical is what? They are highly flammable. And the second chemical that used in our experiment is your hydrochloric acid, that is your HCl 7647-01-0, and hazard related to this chemical is what? They are corrosive in nature. Phenolphthalein 77-09-8, they are what? They are irritant in nature. And potassium hydroxide, that is your KOH, case number 1310-5-8-3, they are what? They are corrosive in nature. Okay, so we use ethanol, hydrochloric acid, phenolphthalein, potassium hydroxide, and the hazard which are related to these chemicals are what? They are highly flammable, so we have to avoid it to open near the flame. corrosive irritant. Okay, so when they are corrosive, so when we are using it, we have to take a care before handling this type of chemicals. Now the next one is your reagent required for this experiment. The first reagent that we required is a alcoholic potassium hydroxide solution. Alcoholic potassium hydroxide solution 0.7 normal. So what should we do? We take a flask of 1 liter, and into it we add 40 gram of potassium hydroxide. What should we do? We add 40 gram of potassium hydroxide. Now low, and this potassium hydroxide should be low in carbonate. Then we add 1 liter of distilled ethanol. So first of all, what should we do? We add 500 ml of distilled ethanol. Okay, distilled ethanol. When this KOH is totally dissolved, then the remaining 500 ml of distilled ethanol will be added. Okay, and the temperature should be below 15.5 degrees Celsius while the alkali is being dissolved. Then the solution should be clear. Then the next chemical is what? Hydrochloric acid 0.5 normal. So what should we do? We prepare 0.5 normal of HCl, determine the exact normality using solution for standard base. Then we have to prepare a phenolphthalein indicator 1% in 95% of ethanol. So what should we do? We take a 1 gram of 1 gram of this phenolphthalein, yeah, 1 ml. Suppose that we have a liquid phenolphthalein, then we take a 1% in 95 percent of ethanol. So we take a 5 gram of this phenolphthalein, and it should be dissolved into a 95 ml of ethanol. 5 ml of phenolphthalein, and it should be dissolved into a, just a minute, phenolphthalein, and it should be dissolved into a 95 ml of ethanol. Okay, how we solve it, you can go see the video related to this topic, that is your solution preparation. This video are already uploaded in our account. You can go and see the video. Okay, now the next one is your hazard precaution and waste disposable. We all know that we are using the hydrochloric acid, and they are what? They are a flammable. So when we are using it, we have to take a care, and we use it into a in a fume hood, and we also follow all the liberty procedure, safety procedure that we that is normal, and like wear a safety glasses, wear a lab coat, wear a mask, wear a gloves, and the waste that generated during performing this experiment should be rinsed with the help of water, and during draining this wastage, we have to follow the common practices outlined by our environmental health, and we have also followed the safety protocol which are given by our institution. Okay, so now see what is written in a slide. Use hydrochloric acid in a fume hood, otherwise adhere to our normal laboratory safety procedure. Okay, one more thing that I want to add here, that the chemical that we uses, it should be properly kept in a storage box, and we have to wear our safety glasses at all time. Wastage like maybe put down the drain using a water rinse, but follow our good laboratory practices, the outlined by our environmental health and safety protocol at your institution. So this is the hazard precaution and waste disposal. Now the next one is your material required for this experiment. First material is required, that is your air, that is for reflex, condenser of 650 long minimum, beaker of 250 ml so that we melt the fat, Bachner funnel to fit side arm, boiling beads, two burette of 50 ml, fat or oil sample. This is what? This is our food sample. This is our food sample. Okay. Then we required a filter paper to fit the Bachner funnel so that we can filter the oil and melted fat. 4 flask of 250 to 300 ml, which is fit to a condenser, and mechanical pipette of 1000 microliter or 1 ml. And along with it, we also required a plastic tips of 1000 microliter or 1 ml. And we are also required the side arm flask. So this is the material that we require for performing this experiment. Now the next one is your equipment required for this experiment. We required an analytical balance. Analytical balance is required for weighing the sample, weighing the sample. Okay, and the next thing that we required is a hot plate or a water bath. Hot plate or water bath are required for a heating. So these two equipments that we require for performing this experiment. Now the next one is your procedure. So here the procedure of what? First of all, we have a beaker. Okay, now if we have a solid sample, then first of all we have to melted it, and then we filter this melted sample or a oil sample through a filter paper, so that if the impurities are present, then it should be removed. Now what happened? Suppose that we have a solid sample. Then first of all, what should we do? We melt it. After melting, we filter it. Okay. Why we filter it? So that if any impurities are there, then it should be removed. Then we weigh 5 gram of melted fat or oil into each of 250 or 300 ml flask. Now what should we do? We have either 250 ml or 3 ml of flask. Then we put a fat of 5 gram melted fat. This is 5 gram. Now after that we added 50 ml of alcoholic KOH into the flask. Okay. Now what should we add? We add 50 ml of alcoholic KOH. Okay. Then we prepare a duplicate of blank sample in which we have only a 50 ml of alcoholic KOH. Okay, when we are preparing a blank, in blank there is no sample are present, but in a sample what should we have? We have two things. One is a sample, and the amount of sample is 5 gram, and one is what? One is a alcoholic KOH of and the amount of alcoholic KOH is what? 50 ml, and blank have only 50 ml of alcoholic KOH. Now add several boiling beads to the flask with a fat or a oil sample. Now we have to add a boiling bead. Suppose that this is your boiling beads. Boiling beads. Okay, along with this sample. Now the next one is your connect the flask with the sample to a condenser and boil gently but steadily on a hot plate until the sample is clear and homogeneous. Now what should we do? We connect this flask to the condenser and boil it, and we boil it until the sample become a clear or homogeneous, which indicate that complete saponification. Okay, and this complete saponification required 30 to 60 minutes. Note down the fume should be condensed as low as possible in the condenser, otherwise fire hazard will be created. Okay, if the fume should not condense as low as possible, then the fire hazard should be created. Then after that we allow the sample to cool down and wash the condenser with the water, deionized distilled water. Then we disconnect the flask from the condenser and allow the sample to cool at a room temperature. And then we add 1 ml of phenolphthalein into a sample and titrate it with a 0.5 normal of HCl. Okay, which sample? Which are already boil boil boil, and the time of boiling is 30 to 60 minutes. And when we titrated with 0.5 normal of HCl, during this process we are already at 1 ml of phenolphthalein, and we titrate it until the pink color should be disappear. This pink color should be disappear is what? This is your end point. Now we have to record the volume of the titrant used, and we repeat 5 to 8 steps for a sample blank with us, okay, and reflects the blank for a same period as used for the sample. Now the next one is your data and calculation. Here what should we do? Here we put the name of the sample, okay, then weight of the sample, then the titrant value. Titrant value is find out by the initial minus final, okay, initial volume of the burette minus final volume of the burette. Okay, then with the help of this, what should we go? What should we get? We get a titrant value, and then we find out the saponification value. Okay, so the formula for the saponification value will be discussed in the next slide. Now here, oil fat sample type tested. Here we write down the name of the sample. Then this is for a blank titration ml. This is for a sample 1 in ml and sample 2 in ml. That is your titrant volume. And here we take a mean of this. Suppose that we have a sample 2. This is for again 3. Then here what should we do? We take a mean of this. Okay. Now the next one is your, with the help of this, we are going to calculate the saponification number, and the formula for the saponification value is what? B minus S multiplied by N multiplied by 56.1 divided by 4. Here, saponification value is milligram of KOH required per gram of sample, and B is what? B is a volume of the titrant for a blank. Okay, and S is volume of the titrant for a sample, and N is the normality of the HCl, and 56.1 is the molecular weight of the KOH, and W is what? W is the sample mass in gram. When we put all this value into the equation, that is saponification value is equal to B minus S multiplied by N multiplied by 56.1 divided by W, then what we get? We get the saponification value. So this is all about the determination of the saponification value in fat or oil. If you have any query related to this experiment, you can ask into a comment box, or for a further detail, you can also follow the ITLS Academy on Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also ask your query to the helpline number that are already mentioned in your slide, and visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share and subscribe. If you have any query, just let us know in a comment box.